Hi everybody. Today we're going to take a closer look at chemical changes. So remember from our last lesson that chemical changes are a change in which a substance becomes another substance or has different properties. A chemical change is also a change that is not reversible by any ordinary physical means. Okay, so for example, mixing vinegar and baking soda would be a chemical change. Burning a piece of wood, seeing soured milk or a rusted nail, or digesting food. All of these things are examples of chemical change. But what causes chemical change? To understand how matter changes, we must take a closer look at the particles called atoms and molecules, okay? You know all about atoms and molecules at this point, okay? So bonds will form when atoms share or exchange electrons. Remember, electrons are on those rings, okay? And the valence electrons, those electrons that are on the outermost ring, they're the ones that form bonds and like Velcro themselves to other atoms, okay? So bonds will form when atoms share or exchange electrons, and this keeps the atoms together and makes a molecule. So in this lesson, you're going to need to remember chemical change, a change when a new substance is formed, physical change, a change where only physical characteristics are changed, okay? The law of conservation of mass, and we'll talk about this further in future lessons, but for now, just know that matter is not created or destroyed. It is only changed, okay? And then you also need to know the word precipitate. And this is a solid that forms as a result of a chemical reaction. Okay, so here's some evidence of chemical changes. So starting materials are going to be called reactants, okay, because they're the things that are going to bond together and react, and then they're going to turn into whatever's ending, a product, because they are what's being made, okay? So think of this like a normal math equation. Reactant plus reactant equals a product, okay? So when we see a product that has a change in color or a change in temperature, has formed gas or formed light, or the formation of a new solid, we know that a chemical change has taken place. In a typical reaction, you will have the same elements both before and after the change, but they're just connected to each other differently. They're maybe in a different order, they're in a different combination. Okay, in a nuclear reaction, you'll have elements that are being created that are different from the reactants. Okay, you usually need more than one of the above characteristics to be called a chemical change. So here are ways to remember chemical change, the evidence of a chemical change. You could say city girls love their phones, or country guys love their phones. City guys, country girls, whatever combination you want to think of. But I want you to remember CGLTP. So the first one, C, color change. It's going to be a new or a different color. G, gas production. If you see bubbles or if you hear fizzing, then you know that there's a gas being produced. Now, we're not talking about boiling, because boiling only happens when you apply heat. That would be a physical change. I'm talking about something that occurs on its own, okay? We didn't cause the bubbles to be there by applying heat. They just happened as a result of the reaction, okay? Now we've got the L for the light production. Think fireflies, fireworks. T is for temperature change. So if it's releasing energy or absorbing energy, if you touch it and you feel it getting warmer or colder, you know that you've got a chemical change happening. And then lastly, the P, precipitate formation. This is when a solid forms and falls to like the bottom of your beaker or your test tube or whatever it is that's holding your substances that are undergoing a chemical change. Okay, first let's talk about the color. So here we have evidence of a chemical change in color. So yes, believe it or not, when the fall foliage comes around each year and we start seeing those leaves on trees change color, that is evidence of a chemical change happening within the leaf itself. Now, we'll also have the color changing on a nail, or when you see rust happen. That would be evidence of the chemical change. Okay, now gas production. So this will happen in the form of photosynthesis. I mentioned before, when you have baking soda and vinegar and you mix those two things, you can immediately hear the fizzing. And so because we know that there's gas being produced there, we know that it's a chemical reaction. The bubbles in soda, however, are carbon dioxide mixed in a solution. So it's not a result of chemical reaction. That's a common misconception, so I want to make sure that we address that one, okay? Okay, now we've got light production. So when we say crack those glow sticks, and this chemical mixes with this chemical, and it's going to have a chemical reaction that emits light. Chemical reaction. Fireworks, chemical reaction, okay? Now we've got temperature change. I mentioned just a minute ago when we mix baking soda and vinegar and how we see the fizz, we know that gas, but if you were to touch it, you would actually feel it get colder, okay? So this would be an endothermic reaction when it's getting colder, evidence of a temperature change, okay? Endothermic is when it takes in heat, which makes it feel cool to the touch. Exothermic is when it's giving off heat. So the hand warmers that we use, I went skiing recently and I had these hand warmers that I could like crinkle, and then it would give off this exothermic chemical change and reaction. Made my hands warm while I was skiing. Okay. Then we've got the precipitate. Okay. So this is, remember, a solid that forms as a result of a chemical reaction. So let's say I take a liquid and I combine it with another liquid and I mix it together, and now all of a sudden I see like little flakes of solid material floating. This would be evidence of a chemical reaction. Also, I like to mention that my son, when he was younger, would leave his little milk sippy cup in random places throughout the house, and I wouldn't find it until a few days later when that milk had turned to a solid and it looked a little bit like cottage cheese. This would be when a precipitate has formed as a result of a chemical reaction, okay? So that would be the final piece of evidence of a chemical reaction. So let's quiz ourselves. Chemical change or not? 2 room temperature liquids are mixed and the mixture gets hotter. If it's getting hotter by itself just as a result of a mixture and you're not applying the heat yourself, then it's a chemical change. Remember, chemical change is something that's happening on their own as a result of a reaction. You are not having to make it colder. You are not having to make it hotter. That happens on its own. You are not changing the color. If it happens on its own, chemical change. When milk turns chunky after being left out, it's formed a precipitate, which is evidence of a chemical change. Putting a substance in the refrigerator and the temperature gets cooler. Well, you're applying the change of temperature. You were putting it in the fridge. So that would be a physical change. When ice is melting, also a physical change. Gas and bubbles after forming 2 liquids or mixing 2 liquids, chemical change. Okay, and the water boiling on the stove. Well, you're applying the heat. You're making it boil. So it's a physical change. So just a hint is which examples created new unique properties. Anything that was there that wasn't there before, that is when you know you've seen a chemical change. Okay, guys, if you have any questions, reach out. We're happy to help. Good luck.